Welcome back to Mr. P Helps with Calculus. This is day 2, in which we are going to be talking about how to find limits. And we're going to be solving them different ways. And one of those ways is using your graphing calculator. Hopefully you have a TI-83 Plus or a TI-84. I wouldn't suggest buying anything higher than that, like a TI-89, but you can. And a TI Nspire. If you buy one of those, I'm going to tell you I have very limited experience with using that calculator. So if you buy it, you're going to be pretty much on your own. It is a completely different interface. All right, so we start with a quick review of what we did on the very last lesson, which finding limits. Feel free to do these on your own time. Actually, I'm going to save a little bit of time right here and skip through this, and you can just watch my last lesson if you didn't catch that. It says a limit is simply, as I explained in the last video, we're talking about what height it is approaching, both the left-hand and right-hand side. So L is our answer. It happens to be our limit, and f of x would be our function, or it could actually list what the function is. And C happens to be what x value we are approaching from both the left and the right hand side. So that's what we're trying to find. So if we have this function right here, and so we have a function on the top and on the bottom, and we're trying to find at x equals 2, what is happening to the function? So what height is it reaching? Now, the first thing I want you to do is explore. So using your graphic calculator, you can put this in. Now keep in mind that when you're putting this in the calculator, do make sure, if you don't have a fancier calculator with the new software, that what you're going to need to do is you're going to need to use a lot of parentheses. So you're going to have to put this numerator in parentheses and then press the divide and then put the denominator in parentheses. And the reason why you're doing that is because you're forcing the calculator to use the order of operations. Then, if you have a newer calculator, you'll be able to put in just the way it is and just the way it looks. It makes it a lot easier, which I highly suggest buying one of those calculators. TI-84 Pluses with the newer software. It actually kind of depends on what year you buy. All right, so we have our X and Y scale. So this is what I'm going to put into my windows by pressing, I actually don't know the actual hotkey. It's the second trace, I want to say, is the window. All you have to do is look at your calculator. You can put this in for your X min, X max, Y min, Y max, and keep your scale basically the same. And then you can see what's happening. And you're going to see what the graph looks like, and you're going to see on your screen that it looks like a fairly normal graph. But there is something interesting happening at this point. If I take 2, which I suggested on the last video, and I plug it in for all of these x's and I solve, I end up getting 0 over 0, which doesn't really make any sense because, of course, you can never divide anything by 0, even 0. You can't even divide itself by 0. That is what we call an indeterminate solution. So it doesn't really make any sense when it comes to algebra. So there's got to be something weird happening at 2. And then we're going to look a little bit further into this. And what we're going to see is if I factor this, then what ends up happening, which you've seen this before, is we end up finding a hole at x minus 2. So 2 is actually a hole. Although on your screen it might look like the function from the left and the right hand sides are actually meeting, they really aren't, because there's actually a hole there that's missing at that point. But there is a height that they're approaching from the left and the right hand sides. So technically there is an answer. Now, even though if I scroll back here, we couldn't find the answer when we plugged 2 in for x here, we are going to be able to find the height when we plug it into this expression. So the limit as x approaches 2 of x squared plus 3, which is what we had left over after we got rid of the hole. If I plug 2 right here, 2 squared is 4, 4 plus 3 is 7. So yes, we found the height of it without using a graphic calculator. I was able to find the height at 2 that both the left and the right hand sides both are approaching, despite the fact that there is a hole there. Now, using our graphic calculator, let's go a little bit further. Now, what does that really mean when the left and the right-hand sides are approaching the same height? Well, if we get closer and closer, on the left-hand side of 2, 1.9 is pretty close on the left-hand side. 1.99 would be a little bit closer. 1.9999 would be even closer. If I use my graphic calculator and I put 1.9 in for x into this g of x function right over here, this is the answer you end up getting. Now, one way of doing this, which might be a little bit easier, and it's nice to know all the little tricks here in calculus, is you might want to just put this equation in your y sub 1 into your calculator, and then just have it solve for a value. Just press second value, put in that number, and then and then put the value in that you wanted to calculate, and it'll pop out the answer for you, so that you don't have to do any of the work yourself. So this is basically just copied straight off the calculator. for these three terms. Now, what I notice is that 6.61 and then 6.96, 6.99 is that the closer and closer I got to a value of 2, the closer and closer the answer ended up getting closer to 7. Now let's look at the right-hand position. 2.1 is a little bit past 2. 2.01 would be closer to 2. It's actually to the left of 2.1. And the 2.001 will be even closer to 2. So every time I add a 0 in between here, it's making it a little bit closer to 2. And if I do the exact same trick, notice what happens to our answers. The closer and closer we get to a value of 2, the closer and closer our answer gets to a height of 7. So what I'm now noticing is, by doing this by hand, that the left and the right hand sides both are approaching the exact same height, meaning that is the limit at 2. 7 is the limit at 2. Even though it didn't work originally, once we got rid of the hole, it was able to work. So it just kind of depends on the scenario of the question. Let's look at example number 2. So this time, if I'm trying to find the limit as x approaches 3, I know that if I put 3 in here, it's not going to give me a real answer. It's going to be an indeterminate solution of 0, 0. Because 3 minus 3, I can clearly see at the bottom is 0, and I could also plug it in at the top and see that it's also 0 up there. So what I'm going to need to do is find that the left and the right hand sides are the same. So what I'm going to do is pick a number that's a little bit less than 3, which would be like 2.99. So if I put 2.99 into here, I should get an answer that's pretty close to 9. If I put 3.001 into this equation, I should also get an answer of 9. But there is other ways of doing it. So what we could do is we could solve that question algebraically, which I'm going to do right now. So this is the exact same question. This is example number 2. But this time we're going to factor out an x on top. So we're going to factor it out. Then we can see that we have a hole at x minus 3. So essentially we have just x squared. If I put 3 in for x, 3 squared is a height of 9. So yeah, no matter which way you do it, whether I'm putting numbers into the calculator from the left and right hand side to see that they approach the same height, or whether I solve it algebraically, it doesn't matter. We're going to get the exact same limit at that x value. All right, sometimes I can use direct substitution. So sometimes, like on this example, and not on the last example, it just kind of depends. If I put 2 in for x, I'm not going to get 0 this time. So this is kind of the easiest case that you're going to get, where you can just literally take your x value, plug it in for x, and solve basically just using your order of operations to get the limit as x approaches 2. There's your answer. And yes, anytime you are, so let me go back for a second, I forgot to mention this. Anytime you are factoring something in limit notation, yes, you need to keep it in limit notation. You cannot stop putting limit notation until you're actually substituting the value of x in. So once I plug 3 in for x, then I can just say, oh, this is really this limit is equal to 3 squared, which is equal to 9, because that's what it equals. That is L. The letter L stands for that is the limit. All right, so example number 4, I'm doing the exact same trick. I'm solving it algebraically by factoring out GCFs and just factoring this trinomial. Once again, I got rid of that x plus 3 whole, so obviously there's a hole at negative 3. So once I've gotten rid of that, what I'm left with, and yes, it's in limit notation, I can plug negative 3 in for x now, and boom, once I've done my substitution, I don't need my limit notation anymore, and I can just evaluate it and find that the L happens to be 6. Now, like I said, you need different strategies because you're going to get different questions. And that's why I showed you a wider range of different ways of solving these kind of questions, whether you're using a graphic calculator, whether you're just substituting the value in, or whether you're solving it algebraically to get rid of a hole. These are all different ways of finding the limits. All right, thanks again for watching, and have a wonderful day. See you on the next video.